Welcome to Joy in Mathematics, a platform created to establish understanding in mathematics. Now, in this video, we'll be taking a look at logarithm to consider the laws of logarithm, how to change base, and most importantly, how to solve logarithm equations. To begin with, the question is, how does logarithm relate with indices? If we go through our series of videos on indices, we'll find out that there are many laws of indices, and most importantly, we can say that a multiplied by a multiplied by a multiplied by a is equals to a raised to the power of 4. And we understand that we have various laws of indices. That means we have the addition law that says a raised to the power of x multiplied by a raised to the power of y is equals to a raised to the power of x plus y, and the subtraction law, as a raised to the power of x divided by a raised to the power of y is equals to a raised to the power of x minus y. We also have the product law, a raised to the power of y raised to the power of x all raised to the power of y is equals to a raised to the power of x y. And we understand that the zero index of indices is a raised to the power of 0 is equals to 1, and the negative index of a raised to the power minus x is equals to 1 divided by a raised to the power minus x. Now, if we take a look at a raised to the power of 4, or let's say a raised to the power of x, we know that our a signifies the base, and the 4, and likewise the x signifies the index or the power. Now, we can relate indices and logarithm together when we understand that the logarithm of a number is the power to which a base must be raised to give an ordinary number. So if y is the number and x is the base, okay, and x is the base, then y is equals to x raised to the power of n, where n, we can say n is the logarithm of y to base x, and in this case our n is the index. So if I have y raised to the power of y is equals to x raised to the power n, we can as well say that log x, log y to base x is equal to n. Alright, so in essence, we can have indices here, and we can also have logarithm. Therefore, we are saying that in our indices settings, we have that x raised to the power n is equals to y, and in our logarithm setting, we have that log y to base x is equal to n. So let's take an example here, and if we have 5 raised to the power 3 is equal to 125, because 5 multiplied by 5 multiplied by 5 is equals to 125. Therefore, we understand our x is 5, our n is 3, and our y is 125. Therefore, if we relate them in terms of logarithm, we realize that our log 125 to base 5 is equal to 3. Now, this is the basis of understanding logarithm. So let's take 2 more examples. If we have 3 raised to the power of 4 is equals to 81, how can I relate this from indices and take it back to logarithm? Then I'm saying that log 81 to base 3 is equals to 4. Okay, log 81 to base 3 is equals to 4. Everything down to our relationship that says x raised to the power, if we have x raised to the power n is equals to y, then log y to the base of x is equals to n. Let's take one last example, and let's say we have 10 raised to the power 3 is equals to 1000. 10 raised to the power 3 is equals to 1000, and writing this in log form, we realize that log of the number to the base, that's 10, is equal to the index, that's 3. So log of the number to the base, log of the number to the base is equal to index. And here we have the number, we have the base, we have the index. Let's take one more. 2 raised to the power of 4, or let's say 2 raised to the power of 2 is 4. And here we have the number, we have the base, we have the index. So in terms of logarithm, we will say log of the number, that is 4, to the base 2 is equal to the index. In our next video, we'll take more examples to understand the concept of how indices and logarithm can be related.